you will end up having a transceiver for this application, a transceiver for this, and all the way down. And you will find that you're going to be using lots of different designs, and you would never be able to cost reduce because you're only addressing a segment of that market. So really, flexibility makes sense going forward in terms of addressing more and more application areas. So really, to highlight this in terms of Lime's effort and market share, we have a huge presence in the US. Almost 60% of our customers are coming from that part of the world. Mainly, a lot of them are around military radio as well as base stations. So already there is a significant deployment of this type of platforms in the US. About 20% of our market comes from Europe, and about 16% from APAC. And hence the reason for me to be here to try and promote our product in this part of the world, and essentially signing up Azio Electronics to promote us here and support our product. In terms of application area, I mentioned small cell base stations. Almost half of our market comes from femto, and these are typically enterprise femto cells. By that I mean cellular base stations operating in offices, shopping malls, schools, places like that. So you would have dedicated small cell base stations offering coverage to a limited number of people. And if you have lots of them around, you would be able to offer coverage as well as high data rate. So as we go to LTE, we believe that type of market share will start increasing. About 12% of our market comes from military radio, mainly dominated by US. And the reason a flexible radio is very important in that market because they do not operate in the standard frequency bands. So they want a transceiver that goes outside the standard, and usually people are not willing to develop a microchip which costs a lot of money to make, a lot of money to develop for a small market. So if you have a flexible radio, these guys could make use of it, and then they could start deploying for their application areas. What is important is about a third of our market comes from the other, and this other is very important. It is all around software-defined radio, and it's all around FPGAs. So we believe a flexible transceiver together with FPGA will offer a huge amount of flexibility, and already we see a significant market building up. Hence, I'm promoting that type of platform going forward to really increase this 30% market to almost 70%, because I believe there is a huge amount of potential in this area. So you already see from a company that has been around for 7 years and has come up with a production unit of this kind only 2 years ago, gaining some such traction in the market in so many different application areas and in so many different geographical locations around the world. So that signifies the start of a very high deployment of such platforms going forward, in my view. So let us talk a little bit about the actual chip itself. I just go through a general description of what this chip does. Any typical transceiver has a transmit chain by which you get a baseband data, which is in digital domain. You turn it into analog. There are some gain stages you go through. There is some filtering operation that happens, and you up-convert that signal to your desired RF frequency. On the receive side, you do the same. You come from RF. You have a number of low-noise amplifiers taking your signal into some kind of a mixer. You down-convert the signal through filters and some gain stages, and you digitize the signal through ADC, and you go to a baseband processor. The baseband processor could be a huge digital circuit which generates any standard you like. It could be 2G, it could be 3G, or 4G and beyond. And as you know, there is a huge amount of flexibility in digital domain, enabling you to do any standard you like. So far, it has been the transceiver which was the limiting factor in all this. You could do only one standard and one frequency band at a time. So we are setting about to change that whole philosophy by having a circuit which is highly flexible, in our case going from 300 megahertz to 3.8 gigahertz. This is really thanks to the synthesizer technology that we have developed inside our chip, which can take you from this frequency of 300 megahertz to 3.8 gigahertz. I would like to emphasize that there is no gap in this frequency. So you can essentially go from anything, any frequency you like, between those two extremes. This is significant because whatever standard that you're using today and whatever standard or frequency band gets released tomorrow, you would be using the same device. You would not be changing it at all. The other important aspect of this device, which makes it field programmable, is the ability to bypass or switch off practically every component within this design. So if you have an application, maybe in a large base station, where you require very high performance from your LNAs, for example, these are low noise amplifiers. In our case, you can bypass them or switch them off and use external ones. If you want to use filtering operation, which is outside the scope of what we provide, and by the way, we do 16 programmable bandwidths in these filters, you can bypass these and use external ones. So essentially, you can adapt this device to be anything you want it to be. And as a result, apply it to so many different applications, as I mentioned in my previous slide, from base stations all the way to machine-to-machine applications. The other aspect of what we have created, again, is high level of integration. We have data converters, which are 12 bits, very high performance, running at high frequency, enabling you to go across all these different application areas, from high performance, high cost, to lower performance, lower cost. Incidentally, you would be able to even bypass these and use your own external components if you wish. You don't have to use our internal ones. So essentially, you will end up with a platform that covers practically every standard and every frequency band you wish. And this is a very important concept going forward for future generations of wireless mobile technology. With all the standards that you have in front of you, we can no longer afford to have dedicated transceivers for each application. It really makes sense to have one which can be applicable to all of these. So it is through this programmability and frequency flexibility that we essentially have a field programmable RFIC, much in the same way as you have for FPGAs. So what we are setting up to do is to really combine the two and create a very powerful set of systems, which I'll come on to that a bit later in my presentation. So to demonstrate this, we have created a universal communication toolkit. This is essentially a board with our chip on it. It's a very small RFIC measuring 9 millimeter by 9 millimeter, providing such flexibility. So on one hand, you have connectors which you can take your RF signal in and out of the chip. On the other side, you have an interface which goes into Altera FPGAs. In this case, it's a standard interface they use across their boards. So this is an HSMC interface that we have built into our evaluation board. So By the way, you will find our product also on the Altera website, which they are promoting, because what we can offer alongside FPGA, as I mentioned, a very powerful system enabling you to do any standard you wish. So with this type of platform, you could be up and running very quickly by connecting your laptop to the board, and we offer